Good morning, everyone. How are you today? I am Teacher Emeline, and welcome to this new day of exploring new ideas and acquiring knowledge in Grade 8 Science. I am very grateful that all of you are present for today's class, and I can feel that you are all excited. I believe that you are now in your comfortable place of learning. But before we will start, please be reminded that we need to read and listen carefully because there are activities that you need to answer. So let us start. For this week, our Module 1 lesson is all about forces. The most essential learning competency or MELC 1 for this module is to investigate the relationship between the amount of force applied and the mass of the object to the amount of change in the object's motion. The specific objectives of this module are: first, define force. Second, identify the effect of force on an object. And third, describe the effect of an object's mass and the amount of force applied on the object's motion. Are you ready, class? Enjoy! Before we will start with our lesson, please be reminded to answer the questions in What I Know part of your module. Do not forget to write your answer on a separate sheet of paper. Again, write your answer on the separate sheet of paper. Lesson 1. Forces can be operationally defined based on observed effects. This means that a force can be described in terms of what it does. However, forces do not always cause motion. It does not necessarily follow that forces acting on an object will always cause it to move. What do you think can forces do? In Figure 1. In Figure 2. How about in Figure 3? Did the object move? Yes, very good. In What's New part of your module, you can find your Activity 1. There is a figure showing the effect of force on a ball. You will examine the ball on top of the table. What condition does the ball shows? Choose the letter of your answer. Write your answer on a separate sheet of paper. We are now on What It Is part of your module. You are about to describe the forces acting on an object using the following terms. First, magnitude. Second, direction. Third, point of application. And fourth, line of action. You are also introduced to two types of forces, namely contact force and non-contact force. To describe a force, you must also be familiar with balanced forces and unbalanced force, as well as net force or resultant force. To accurately describe the forces acting on an object, Figure 7 shows the physical concept illustrated on a ball using the following terms. First, magnitude. This term refers to the size or strength of the force. It is commonly expressed in Newton or capital letter N for meter, kilogram, second system. In the International System of Units, Newton is commonly used, which is named after Sir Isaac Newton, an English physicist and mathematician. Second, direction. Points to where the object goes. The direction of the arrowhead indicates the direction of the force. Third, point of application. The location where the force is applied. And fourth, line of action. Is the straight line passing through the point of application and is parallel to the direction of the force. Now let us go back to figure 7. Can you find the magnitude, direction, point of application, and line of action? Very good! Let us continue. There are two types of force: the contact forces and non-contact forces. Contact forces are forces where objects touch or in contact with each other. There are examples of this contact force. First, applied force. A force given to a person or object by another person or object. Its symbol is capital letter F, depending on who or what applies force to the object. Like in this figure, the boy applies the force to a wall, so we denote it with F subscript boy. Second, friction. Friction is the force acting against or opposite an object in contact with, which makes the movement of the object to slow down. Friction always opposes the motion of an object. Its symbol is written as capital letter F with small letter f on the side, or capital F with subscript small letter f. In the figure, you can see applied force is directed to the right, while the frictional force is directed opposite to the applied force. It is directed to the left. Third, normal force. Normal force is the force that acts perpendicular to the surface of the object in contact with. Its symbol is capital letter F with subscript capital letter N. In the figure, you can see that the normal force is perpendicular to the surface of an object. Fourth, tension force. Tension force is the force applied to a string, rope, chain, or cable. Its symbol is capital letter T. In the figure, you can see the tensional force that acts on the rope of a hanging ball. Do you have any questions? If none, then let's continue. Another type of force is the non-contact forces. These are forces where objects do not touch or in contact with each other. Here are examples of non-contact forces. First, gravitational force. Gravitational force is the force of attraction between two objects. In the case of the Earth, this gravitational force causes objects to fall down to the ground. Mass and distance of these two objects affect the gravitational force that holds them. The bigger the mass of the object are, the bigger is the gravitational force between them. The closer the objects are, the greater is the gravitational force between them. Its symbol is capital F with subscript small letter g. Here is a figure that shows the gravitational force between the Earth and the Moon. Earth has bigger gravitational force over the Moon. The weight of an object with the symbol capital letter W is an example of gravitational force of the Earth towards the object. A Another figure which shows the weight of a book on the table with normal force. Second, magnetic forces. Magnetic forces are forces exerted on a field of attraction or repulsion, as in the case of magnets and other magnetic material. Magnets and magnetic materials have two poles, north and south poles. Attraction occurs when two poles are not the same, a positive and a negative, while repulsion takes place with the same poles, positive, positive, or negative, negative. Refer to figure 14. Is there attraction that may occur when two poles are not the same? How about with the same poles? Another way to describe a force is to know the magnitude and the direction of the force. In figure 15, you can see two teams pulling a rope with equal magnitude of force on the rope but in opposite directions. Neither team can make the other team move. Why is that so? Do you know the answer? Yes, forces that are equal in magnitude but opposite in directions are called balanced forces. These forces do not cause a change in motion. When balanced forces act on an object at rest, then the object will not move. When you push a table and the table moves, unbalanced forces are present. Unbalanced forces are forces that cause a change in the motion of an object. Unbalanced forces are not equal in magnitude of force and in opposite direction. As you can see in figure 16, one of the team exerts greater magnitude of force than the other team. So the forces applied would no longer be equal. So one team would be able to pull the other team in the direction of the greater force. Which team wins the game? Is it force A or force B? Very good! In an object, there may be several forces acting on it. Net force or resultant force is the sum of all forces acting on an object. Two or more forces in the same line of action exerted on an object are balanced if their effects cancel each other. When an object is at rest, a zero net force would make the object remains at rest. Moreover, when the object is moving, a zero net force would make the object maintains its velocity at a given time interval. When the net force is not zero, the object's velocity will change. A net force exerted to an object at rest may cause the object to move. In a moving object, a net force will increase its velocity when the force is in the same direction of its motion. If the net force is in the opposite direction of the object's motion, the force will reduce the object's velocity. When the net force acts sideways on a moving object, the direction of the object's velocity changes. Do you have any question, learners? Are you ready to answer your activities, class? I guess you are. In what's more part of your module, you are tasked to answer Activity 1, Forces an Object at Rest, Activity 2, balance of forces, and Activity 3, unbalanced forces. In what I have learned part of your module, there are 10 questions you need to answer. In what I can do part of your module, there are 3 problems you need to answer. Assessment part, there are 10 questions you need to answer. Additional activities part of your module, you need to answer 2 problems. Take note that all answers should be written on a separate sheet of paper. Take your time in answering. Do not leave any blank. Enjoy! So it has been a great day to all of us, for we have learned something new. Once again, I am Teacher Emeline, and see you again for another learning experience. Good day, learners!